It's a good team. Alright, looks like we're live. Hello everyone and welcome to yet another Azuzin session. Let's make a little bit of an announcement and officially start the stream. So let's just wait a little bit for Discord, of course. So red circle live on Twitch. And what are we doing today on twitch.television? So today we're simulating rope with Jai. That's exactly what we're doing. It's kind of an interesting topic, and it's not particularly what you think it is, right? So you think it's related to Advent of Code, but it's kind of related to Advent of Code, right? So as some of you probably know, there is Advent of Code going on right now. And I'm participating in it, but I'm not really making a content out of that because I don't really want to stress myself on that. Right, and to be fair, I don't really know how to make an interesting content out of Advent of Code. I suppose it's not like, if you're not like a highly competitive, like super cool competitive programmer, you can't really make an interesting content out of Advent of Code, but I'm solving it for myself. Right, so today's problem was rather interesting. So it was about simulating a rope, right? But you were simulating the rope on a two-dimensional grid, right? So, at the end, the second part, if you don't want spoilers, probably you shouldn't watch the stream. But yeah, so essentially you end up with like a rope with sort of like 10 knots, right? And you're simulating this this rope and just like, you know, compute how many places the tail like visited in this grid. So what I was thinking, it kind of inspired me to implement this, but with visualization and continuous, right? Because this specific rope, it's actually discrete, right? It is actually discrete and it like follows this grid and stuff like that. But I want you to actually make something that is analog, like sort of continuous, and actually sort of simulates these things. So, and I've got a following idea. So let me open my Paint so I can draw and demonstrate what exactly. I'm sorry if it was too loud. Right, I've got the following idea. So imagine that we have knots, right? Certain knots. And each node, it has a particular position, right? It has a particular position, and also it has a particular velocity. Right, and essentially, so let's say that this is the head, right, so this is going to be the head, right, and this is the tail, like so. And essentially, on each frame of the simulation, on each sort of tick, I think it will be correct to call these ticks. On each tick of the simulation, we basically update the head according to its velocity, which is to move the head to that particular direction. And then we look at the tail. Okay, did the tail become more far away from the head? Well, if it became more far away from the head, we adjusted velocity to actually point towards the head, and the further away the tail, the faster is going to be velocity. So the closer it is to a certain distance that we defined for between the head and the tail, the slower it's going to become. If it's actually too close, right, so the distance is actually less than the d that we defined, we're going to define the velocity in the opposite direction, trying to bring it back to that specific distance, right? And that way, so on each tick, we sort of like try to keep them at the same distance, right? So, and then once we've done that, we can actually try to add more knots that sort of follow the same idea, but we update their velocities like in a chain reaction. Right, and then just see how this entire system would work. We may also try to maybe even add some gravity in the future, right? So it's not only going to be affected by like the velocity towards this sort of thing, but also by the gravity and stuff like that. And maybe we can also like define some bodies that have several nodes and stuff like that. But for now, I want to start with just two things, with just head and tail, and see how this entire system works, and maybe add a system that allows you to grab the head and just start moving it around and see how this affects stuff. So yeah, that's basically the idea that I wanted to implement. I actually wanted to do something like that for quite some time, but I didn't have a more or less solid idea how to implement that, and today, because of the advent of code, I got an inspiration to do that. So that's going to be the idea for today's stream, and we're going to implement that using Jai, because why not? We haven't programmed in Jai for quite some time. There has been several beta releases, so I think the most notable one is finally we can use non-constant values in the structure literals or something like that, but I'm not sure if too many people care about it, right? So at least the people who are not in beta, right? So, and on top of that, Jai has a built-in graphical library, so we can just go ahead and visualize it right away without worrying it too much. So the cool thing about Jai is that the batteries are basically included. Right, so some people quite often say that in 2022 the batteries included is kind of a weak selling point because we have these fancy package managers that can install ourselves all sorts of batteries and stuff like that, but I think it's actually not true. It's kind of cool that I can just download Jai and it just like has everything. Like I don't have to think about what is the graphical library of the month that I have to use today, right? And then worry that in a month it's going to be a different library and my application is obsolete or something like that. No, it has a built-in graphical library which is part of the standard library, and I can just rely on that. That's very, very convenient. So I just download the thing, it has everything, don't have to think about it, don't have to follow the trends, just get the shit done. You know, I kind of like that. And I think this is kind of stuff that actually made Python popular at some point, right? Anyways, so let's go ahead and try to do that. So let me see. So I'm gonna create the folder called rope Jai, right? Because I don't really know how I'm gonna call this thing, and we'll see. Okay, so the entry point looks like this. You have to define a main, then something like that, and then you have to print hello, not sailor, but seaman, right? So because sailor is already very old, today we say hello seaman instead. Right, so let's import basic, and let's just try to compile this entire thing and see if it still works. Maybe the language has changed so much that it doesn't work like that anymore. It seems to be working, look at that. Look how much time it takes to compile the hello world. Look at that. Remember how much time it takes for nim to compile hello world? Does anybody remember? I don't quite remember. So main nim. Main.nim, there we go. Right, and then I can do echo hello world. Right, and then I can try to do opt nim. They have nim, there we go, bin, nim, c, main, nim. What is it doing? Why does it even need a progress bar? Like, what the fuck, nim? What the fuck? It needs to parse 2 config files. It also needs a progress bar while it's parsing these config files or doing something else. And it's just like, what the fuck is going on? Dude, that's it. One more time, that's it. Seriously, what the fuck is wrong with me? I have no idea. Anyway, come on. Anyway, so let me see if it actually, you know, says hello seaman. There we go. So hello seaman does in fact says hello seaman. So first thing, we probably want to create a window, right? So as far as I know, in the standard library of Jai, we literally have create window library. Yeah, there's like a window creation library, believe it or not. Right, so you can import window creation. Right. So it's kind of interesting, like people usually Google like how to create window in this language, and you get some sort of like a name of the library of the framework, and you have to do that and that. If you want to create a window in Jai, you import window creation. Like, what the fuck did you expect? If you want to create a window, just import window creation, right? If you want to sort an array, what do you import? You import a sort module, Right, and in fact, in Jai, as far as I know, there is a sort. Yeah, there we go. There is a search module that even has bubble sort if you want to, if you want to use it. Right. It also has a quick sort, but it also has a bubble sort. Right. So it's pretty straightforward. You want to do something, you just fucking import that without any freaking bullshit. That's why I respect this language. Anyway. So how do we create a window? So there's a couple of examples, I suppose. So you literally just create a window. You have to specify the size and blah blah blah. Might as well actually copy paste some stuff in here. So main.jai. So you create a window. The window. I'm not sure why it is not defined like that, so I'm gonna actually define it like that. Then we are organizing the event loop, right? And we are basically updating all of the events. Right, and then we iterating through all of the events this frame, right, and if we encounter an event quit, we just quit the entire application. I guess that's it. I guess that's it. Okay, so it's actually simpler than SDL, to be fair. Okay, so sort, we don't really need sort, I'm gonna remove that. Okay, so there's a little bit of a problem in here. So, well, the language, I mean, the language is kind of cool, but you have to keep in mind that it's unfinished, right? It's actually kind of cool, right? So essentially, if there is something good about the language, you prize the language. If there is something bad about the language, you can always fall back to, it's unfinished. So, I mean, what did you fucking expect from unfinished language? Am I right? Or just, but if there's something good, yeah, that's a fucking language. That's the language of the future. If you don't like something, it's unfinished, right? So it's actually pretty convenient. I'm pretty sure that's the reason why this language is not released yet, so it always has this fallback to say that it's unfinished. It's unfinished. What did you expect? I don't know what you expect. It's unfinished language. Anyway, so what we have? We have undeclared identifier. So we need to define the width and height of the window. Right. Let's go ahead and do that. So this is going to be height. And this is going to be that. There we go. So let me rebuild everything. And what do we have in here? So update window events. I think this is located in another. Yeah. So handling events is actually located in the input module. Right. So on top of window creation, we also have to import the input. And there we go. So we created a thing, and we just created a window. Believe it or not. So there we go. This is the window. So that's pretty cool. So it doesn't really refresh or do anything, right? So as you can see, but that's the window, which is kind of cool. So let's see what other stuff we can do with this example, right? So specifically in here, we don't really do anything interesting, right? And I suppose to do something interesting with the window, we have to use simp, which is basically the SDL of Jai. So let's take a look at some of the examples in here. So it uses the create window and stuff like that. So you also have to essentially set the render target, right, to do the rendering. Let me quickly try to do that. So I created the window, then I set the render target to the window, right? So this is that. And what else do I need to do? So I did this stuff. So I'm not going to handle the window resize for now, not really care about this thing. So reset temporary storage, sleep, blah, 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 blah. Drop one frame. I think the most interesting stuff is located in this function. So we clear the render target, right? So we just clear the render target. And after that, do we do swap? Yeah, we do in fact do swap, right? And we just swap the current window. There we go. And if I try to, this is not really what I wanted. I wanted to actually first rebuild my entire stuff. Okay, so we don't have simp, and this is because we have to import simp. Right, but here's an interesting thing. I'm using simp as the, namespace in here, but if you just import a package or a module, it will import all of the names right in here. If you want to use it as a namespace, you have to do something like this, if I remember correctly. Right. So to avoid collision with different functions for different modules. And there you go. So we now have a caller in here. How cool is that? And look at the size of this example. It's actually rather small. So this is how much code it takes to create a window and start drawing on that window in Jai. So that's pretty cool. All right. So this is basically a rope simulation. So let's actually change its title if I try to recompile. So I'm gonna take a look at the title. So it says rope simulation. There we go. That's pretty pogue. So I don't really like that it has this red tint to it. So I actually want it to be like grayish, right? So it's kind of similar to the background of my editor in here. So I really like this specific background. Okay, that's pretty poggers, isn't it, my friends? You can tell this was made by someone who does graphical programming. Exactly. Right, because it's just like, it's pretty straightforward and bullshit free. Because if you do graphical programming, you have to deal with so much complexity that you sort of like develop an allergy to any sort of additional complexity, so you try to simplify things as much as possible. It's just like, yeah, it's insane. What's interesting is that I like that there are examples, like I didn't even read a single line of documentation. Have you noticed that? I only looked at the examples. I just went through different modules. Each module has its own piece of example, and I just stitched together this thing out of the examples that were part of the modules without any documentation. Isn't that cool? This is how documentation should be. The code is the best documentation. It's just like, you have a module, and this is how you use the module. There you go. Right, if you want more details, just go into the module and read the source code. And the source code is actually pretty straightforward as well. Right, it's just like, yeah. Anyway. Okay, so I'm just looking at the chat. People eating borscht in chat, which is kind of cool. So, what we need to do, right? So we need to be able to draw knots, right, for the rope, and then we also need to be able to connect those nodes. As far as I know in Simp, right, if we take a look at the Simp, right, we have a way to render like quads and whatnot, right? So generate quad. So draw. So let's take a look. Okay, immediate. So this is immediate API, immediate quad. There you go. Right, so we have immediate quad, and we just put vertices in here. But as far as I know, you can also render immediate triangle, right? This is actually kind of cool. So you can draw immediate triangle. You simply provide the vertices of the triangle, then you also provide the colors of the triangle and UV coordinates. You can also provide normal if you want to, and I suppose depending on what kind of shader you put in there, you will be able to also put the textures in there. It kind of reminds me of Olive C that I was developing, but it's actually backed by OpenGL. So let's try to do immediate triangle. Let's try to render immediate triangle and see if we are able to do something. So as soon as we have triangle rendering, we can pretty much render any sort of shape, right? So essentially what I need is circles, right? As far as I know, Simp doesn't really have circles, but you can draw them with triangles. You just basically interpolate the circle with the triangles and you get some sort of a circle. It's kind of a, right, it looks like more like a, you know, like a hexagon or something like that, but we can work with that. And also, once we have a triangle, we can draw thick lines, right? Because I want the segments of the rope to be thick lines. I can draw them as rectangles, right? I can draw them as rectangles, but each rectangle is basically going to be 2 triangles, right? So out of the triangles, I can just basically build any shape I want, right? Which is precisely what I need. That's pretty cool, I think. Okay, anyway, so immediate triangles. So let's first do the following thing. So this is gonna be P0, P1, P2. Here, I think I'm not gonna bother with UV coordinates and normals. Luckily, they have default values, right? Jai has default values, right, which is kind of cool, unlike C. And for the colors, we can try to do something like I don't know, red, green, blue. Right, and I wonder, I'm pretty sure it doesn't really have predefined constants for that, but we can always define them ourselves. Right, we can say that red is a vector 4, where we have something like 1, 0, 0, 1, so this is red. Green, we have to have a dot in here, it's going to be that, and the blue is basically that. There we go, so we defined all of those things, boom. There we go. So the other thing we need to define is basically P0, P1, and P2. P0, right, P1, and P2. So in terms of that, let's try to, as far as I know, the coordinates for the window in SIMP is 0 is left bottom, right? 0 is left bottom, so we'll have to take that into account. But maybe we can always just, whatever. So make vector 2, right? So P0 is going to be left leg, so this is going to be 0, 0. By the way, immediate, it's a vector 3. Notice that. That's actually very interesting. So it supports 3D. Oh! But does it... Okay, so it's an immediate quad, but I wanted immediate triangle. Does it have immediate triangle that is 2D? Right, I haven't noticed that. Immediate triangle. I guess it just doesn't really matter, it just depends on the projection, so I think we can just set z to be 0, right? So I think we can just set the z to be 0 and see how it goes. Right, make vector 3, so this is going to be that. Then width is, the right leg is going to be this window width, right? Window width or something like that, window width. 0, and this one is going to be 0, and then make vector 3, so this is going to be in the middle, right? So we're going to divide it by 2, but this time this is going to be window height, right? And it's also going to be that. So I'm not sure if making z0 is going to make it work, but we'll see, So let's actually try to run this entire thing. So vector 4, vector 4 is available in math, so we have to import math. There we go. So what else do we have? Immediate triangle, it's part of the SIMP, so let's actually try to do that. And we didn't get anything. Okay, so that's interesting. So it's kind of expected. What if I make z equal to 1? All right, so that didn't work. So we can try to see how it usually worked with other things, because I remember there was immediate quad that used 2D vectors, right? So it uses 2D vectors. Because here we just have 2D, but then it's not that different. It uses just put vertex, right? It just uses put vertex. And put vertex, I suppose, has 2 variants in here. Alright, so it has 2 variants in here, and this is the vector 2. And as you can see, it just sets the z to 0 and normal to 1. And UV, U and V, it's just set to something. It depends on what it sets it to. Right, it very much depends on what it sets it to, so, but I'm not sure if UV coordinates are that important. So immediate, what was immediate quad? Okay. Okay, so it actually explicitly sets UV coordinates, at least, right? And when we do immediate triangle, it doesn't set UV coordinates to anything. I have a feeling that we need to set them to something, right? If we want them to, to represent what we actually mean here. But the question is, like, what is it going to be? Let me see. We can say UV0, UV0, UV1, UV2, right? UV0. And in here, immediate triangle, so UV, it's actually vector 2. Right, and in here, so this is going to be 0, 0. UV1 is the right part, so that means it's going to be 1, and UV2 is the middle, so that means it's going to be half. But this one is going to be 1, right? If we just like follow the conventions, and it still doesn't work, surprisingly. It still doesn't work. Okay, so we can try to do the other thing, right? So we can try to do the other thing. I remember for sure that immediate quad worked. Immediate quad worked. So let me see. Immediate quad. So yeah. So you can just provide this thing and you can just like do the quarters. So let's give it a try. So if I set this thing to something like, I don't know, do I want it to be, I want it to be like padding, right? So this is going to be pad, so this is pad, and then in here is going to be width minus pad, then height minus pad, and the color, in terms of color, we're going to have something like, let's put red in here, right? So let's put red in here. So this is going to be pad, and pad is 100 in here. So let's give it a try. So it doesn't like that because we're using the colors. So the colors are shared between both of the parts of the code. And let's see. So this one is the window width, right? So this is the window width. This is the window's height, and there we go. So what else do we have? So it's part of the simp. Sure. It still doesn't work. So the problem is probably not with what kind of stuff we're providing, right? Because even that stuff doesn't work. All right, I remember that this thing worked. So I pretty much remember if this thing worked. I remembered, yes. You have to set the shaders. I keep forgetting about that. This is such an intuitive API, but it's unfinished. It's a little bit unintuitive, but this is because it's unfinished. Right, this is because it's unfinished, not because the language is bad. No, it's unfinished. It's unfinished. So the thing I forgot to do, you have to set shader, right? Immediate set shader, and it's probably also put in the example, so I probably missed that thing. So what do we have? Here is the example shader. Yeah. So set shader for color. That's what you have to do. That's what you have to do. The language is not bad. Don't dare to think that language is bad. It's unfinished. If there's something good, that language is good. If something bad, language is unfinished. Remember that. Freaking remember that. Anyway, so that's so easy. I really like that. So I should do that as well. I should make a project. Isn't that something that I do all the time as well? Like none of my projects are ever finished. Yeah, that's actually a very good argument. So this is really cool. This is very cool, right? Yeah, so never finished project. If somebody criticizes your project, it's unfinished. What did you fucking expect? Alrighty. Okay, so here is the red. So okay. So now the time has come to switch to the triangle. The time has come to switch to a triangle and witness the beautiful rainbow triangle. Isn't that beautiful? Look at the beautiful rainbow triangle. Okay. Okay, so we got some subs. I've seen some subs. Just a second. Mr. Foes, thank you so much for Twitch Prime subscription. Thank you. Hope Twitch pays you out back pay when war is over. Probably not. So like it's not in this decade. So yeah, but thank you so much for gifting the money to Jeffrey Bezos. Jeffrey Bezos really appreciate that. So that's very cool. Thank you. So that's very pogue. That's very pogue. So how are we gonna be? So that also means that we probably don't need UV coordinates, right? So it's kind of interesting how much code I wrote out of the wrong assumption, right? I made a wrong assumption, and I added the thing about UV coordinates, but I don't actually need UV coordinates, right? So now I can even simplify this entire stuff, and look how much simpler this code has become. Look at that. It's actually super cool. Super cool. So the question is, how can you render a circle, right? I want to be able to just like put circle, right? Put circle, and essentially I want to provide the center, like where the circle is located, so this is going to be a vector 2. And also I want to provide the radius, which is the float, right? So this is going to be the float. And in here, we're going to just simply, do something. So we probably need the resolution of the circle, right? The resolution is essentially how many segments we're going to have for the circle. Let's say we're going to have 10 of them. Let's actually start with 6, right? So we can clearly see how exactly we're rendering those things. So then we need to take the circle and divide it by the resolution, right? So the whole circle is 2 pi, and we divide it by the resolution. So pi is already float, so I hope this entire thing is going to be float, right? So, and this is the angle step. Right, so it's a step angle. Let's call it step angle. Step angle. There we go. So, and then I'm iterating each individual segment, right? So this is going to be something like that. And what I need to do is just essentially, maybe I should draw that. Isn't that a good idea? Alright. So let me do my paint. Okay, good. So we have a circle. This is a very shitty circle, not gonna lie. Alright. So essentially we split this entire thing into like certain sections and whatnot, right? So let's suppose we're gonna split it like that. Right, and there you go, we have a bunch of triangles, right? So we have to just iterate through all of the triangles and render them like that, right? So it's more of it's going to be sort of like a polygon, right? Right, cool. It's going to be more of a polygon. I don't know how to pronounce that, I didn't speak English, I'm sorry. Anyway, so we need to do immediate immediate triangle. There we go. So it probably would make sense to accept the color. I think that's a very good idea, right? Because that's the color with which we want to render this entire thing, of course. So the immediate triangle. The triangle starts. We can just put P0, P1, P2, and the color is going to be just color. There we go. So P0, let's say that P0 starts at the center. There we go, so that's going to be P0. P1 is going to be the current thing, meaning that we just take cosine of step angle multiplied by current thing, multiplied by I. Let's actually say that it's I. So any for loop implicitly creates a variable called it, right? If you just don't define any variable, you can refer to it via it. Right, so we have cosine it, then the y is going to be sine step angle it. There we go. And this creates a vector, right? So this creates a vector, but it's going to be a unit vector, right? So with the length 1, right? So then we have to multiply by a radius. As far as I know, vectors override multiplication operators, so I can actually multiply it like that. So this is going to be radius, and then I need to add the center. So this is P1, right? So I take the center and I just like make another point starting from the center, right? So then I need to get another point, but this is just basically it plus 1, right? So I have to do something like it plus 1, so this is the next one, and there we go. So that should be it essentially. Okay, so let's go ahead and create a circle. Let's call it immediate circle, right? Immediate circle, I think that's a good idea. Immediate circle. So the center is going to be at window width divided by 2 and window height divided by 2. The radius, let's say, is going to be 100, and the color is going to be red. There we go. So we're trying to render a circle, right? So we have a P1. This one has to be a P2 actually. What else do we have in here? Immediate circle. Too many arguments. What's wrong with that? Oh, this is because this thing has to be a vector. So let's actually do vector 2. There we go. Now, what else do we have? Immediate vector. This is part of the simp. Emacs. What the fuck are you doing, Emacs? Oh, right. What else do we have? It wants P3. Oh, okay. I wonder, so there is a way to sort of like create, nah, we'll probably have to do it like that. I'm just thinking, is there an easy way? Is there easy way to create P3 out of P2? The circle is imminent. Enter shelter immediately. Yeah, exactly. I mean, it's immediate. The circle is immediate. Enter shelter imminently. So what that means, I have to go to the math module, right? I have to go to the math module, and in the math module, I need to find make vector, right? So make vector 2, or maybe even make vector. Oh, you can actually make vector out of a single thing. Oh yeah, that's so cool. This is what I was looking for. Thank you, John. Thank you. You realize that this is a very common shit you want to do. You want to be able to take a vector 2 and slap a z on it. Yes. Thank you. Holy shit. God language. Okay. So, and that's literally what I want to do. Make vector 3 and just like put a 0 in here. Right. And maybe I can even do something like this. Alright, so make vector 3, 0, make vector 3, 0, make vector 3, 0. There we go. So I'm gonna also put this stuff, and where's the color? There we go. Cool. Okay, so let's just try to recompile this motherfucker. Boom! This is a circle, and if you disagree with that, I'm gonna ban you. Okay, so let's actually try to increase the resolution of the circle. So essentially, to make it look like a circle, we need more edges, right? So let's actually make like 20 of them. What about 20 edges? Does it look like a circle? It's starting to look like a circle, right? So it's starting to look. We can make 30 of them. Yeah. So this already starts to look like a circle. We can actually work with that. So, and this is what I'm gonna use to denote the knots. Right, so circle enough, yeah. So if it doesn't really look like a circle enough, you can just add more edges, and there you go. It's good to go. Cool. Maybe I'm gonna actually put these things in here, and let me do it like this. So this is the circle resolution. Cool. So we have some sort of like a configuration thing in here. So let's also put color red in here and also align everything like so. Boom. Let's recompile. So color red. And now this is the circle resolution. And this is another circle resolution. Cool. That's pretty poke. So the next thing that we want to be able to do, we want to be able to draw lines, right? But we want to be able to draw thick lines, right? Because we're going to have like two circles, right? Two circles, and they're going to be connected with some sort of like a junction, if you know what I mean, right? So, and this has to be like a thick line so we can clearly see. So the way we're going to do that, right? So we're going to basically draw it as a rectangle, but the rectangle is going to be split into two triangles. Right, so that's basically the idea. So let's call the function that draws this kind of shit immediate thick line, right? So, and it's going to accept 2 points, the begin and the end, p0 vector 2 and p1 vector 2, and we're also going to accept the color. There we go. So, and this entire thing should actually, well, we should also accept the thickness, right? So this also has to be thickness. This also has to be a thickness. So let's do a little bit of a drawing. Though, to be fair, we already have a quad function, right? We already have a quad function, so probably we don't even need to split anything into triangles ourselves. We can just ask John to do that. I mean, the John's code, right? So when I'm calling to John's code, I feel like I'm asking the John himself. I'm joking. That's weird. All right. So essentially we have 2 points, right? So it's going to be P0 and P1. Essentially, what we want to do, right? We want to figure out how to turn this into sort of this triangle. No, not triangle, but rectangle, I'm sorry, right, into this sort of rectangle. To do that, we need to find a vector that is perpendicular to this specific vector, right? So which points to here. So here is an interesting thing. So let's actually imagine that this vector, like this specific vector, is P1 minus P2, right? So this is the vector that we have. So let's actually call it V1. So, and this one is going to be V2. So this is V2. We need to somehow find V2. How can we find it? So what's interesting is that what I noticed is that you can take any vector, basically any vector. So let's actually take a vector 1, 2, and this one is going to be 1. Right, let's take a vector which is 2, 1. Right, 2, 1. So this is the vector that we have. You want to rotate this vector 90 degrees. Right, you just want to rotate it 90 degrees. When you rotate it 90 degrees, what you get effectively is something like this. You get this vector, which is -1, as you can see, -1, 2. And it actually works with any vector, right? It actually works with any vector. So effectively what you have, if you have a vector x, y, you can rotate it 90 degrees by doing something like -yx. So that's how you rotate this thing 90 degrees. So, and that's precisely what we can do in here, right? That's precisely what we can do. We can just say that this thing is going to be V1 minus V1y, and then V1x. But on top of that, you probably want to normalize this entire thing, right? So you'll just basically divide it by the length of this entire shit, right? So you'll divide it by that as well. Right. So you'll normalize it, and this is how we'll get that. So, and once you get such vector, right? Once you get such vector, knowing the thickness, you can basically construct this entire stuff, right? So this entire rectangle, if you want to. So you can get these 4 points. You can get these 4 points and just draw the quad of those 4 points. It's equivalent to multiplying by 90 degrees rotation matrix. It is true, right? As already said multiple times, I consider matrices not as the solution to a particular problem, but rather a way to encode a sequence of operations. You can always do this sequence of operations yourself manually, right? It's just like a way to take operations and just encode them and sort of like compress them into like this tight, neat matrix, and maybe also implement that on a hardware level very efficiently, right? So for me, matrices were always just a way to encode things, and I was always interested into what exactly they encode, right? So for me, when I had certain problem and people propose the solution, just multiply by that matrix. This for me is equivalent of I have a problem with a certain thing and I'm looking for open source solution, and somebody suggests, oh, just use this proprietary closed thing and don't think about it. Like for me, solution, just use this matrix and to think about it sounds like that, because matrix is just like this binary closed proprietary blob that you have to decode and understand exactly what it's doing. You know what I mean? It's kind of, maybe it's not a particularly great comparison, but yeah, this is how I see that. But maybe I'm also wrong. I'm not a mathematician. Maybe there is some sort of depth to the matrices that I'm missing. But, you know. Proprietary matrices, yeah. Engineer mindset, probably. Maybe I have an engineer mindset. Okay, so immediate thick line. So let's do the following thing. We're gonna create V1 P1, P0. There we go. So as far as I know, we already have overloaded operations for like minus in here, so we don't have to worry about that. Then what I need to do, I need to basically just make vector to v1y, but minus v1x. And I would like to normalize that. So as far as I know, there is a way to normalize this entire thing in J. So let me actually find normalize. Normalize, yeah, there we go. So there's a lot of different normalizations. So this thing can only normalize vector 3. Oh, that's a very interesting. Yeah, I remember seeing that. It's a very elaborated normalized function. First of all, it accepts the epsilon by which you compare with the length of the vector, and if the vector is too small, instead of dividing by that vector, we have some sort of a fall. This is actually really cool. Right. So essentially, if it's less than epsilon, we consider the length to be 0, and division by 0 is not defined, so because of that you have a fallback. This is so cool. And like, I wonder why is it not implemented for like two-dimensional things? I remember actually encountering this function. This is such a cool idea in my opinion. Because like this thing kind of makes you remember that like what's gonna happen if the vector is too small, because quite often people forget to handle that situation, to handle that case, right? So yeah, you want to normalize the vector, but what if your vector is 0? What if it's 0? What you gonna do? You have to handle that probably, right? You're probably gonna forget about this thing. Okay, so I suppose there is no version for vector 2 because again the language isn't finished. The language isn't finished. Okay. Any criticism? The language isn't finished. Alright, so let me see. And let's just do 2. So fallback. And really, that's a good question. So if this entire thing is 0, what we're gonna be doing? So we're normalizing. It is 0 only if the entire, yeah, it is going to be 0 if the length is 0 effectively. In that case, do we want to even render anything? Probably not, right? Probably not. So maybe because of that I'm going to actually do all of that manually. Right, so I can just basically take v2 length, right? So it's going to be sqrt v2x plus v2y, there we go. And if v2l is less than a certain epsilon, right, and epsilon, let's maybe define it as something like, I remember Jai didn't really support this scientific format, so does it really support anything or not? Right, if it's less than this epsilon, in that case we can just return out of the function. I think that's a good way to work about that. And then we can just go ahead and divide this entire stuff by the v2l. Right, so it's going to be that, and this is going to be that. Cool. So that's actually a pretty good way to do that. So let me try to recompile this entire thing. Right. Now j lengths main.j. So it doesn't really support this entire thing, so we'll probably really have to like manually do that. Yeah, we'll probably have to do manually that. Okay, so there is no, yeah, let's remove this entire thing. Okay, seems to be compiling. Cool. So now, what do we need to do? So the first point, P0 plus plus V2, but multiplied by half of this thickness, right? Multiplied by half of the thickness. So this is sort of like the first point. We can consider this the first point. So, and then the second one is going to be P0, but minus that thing. right? So this is sort of the second point. And we can repeat all of that for P1 as well. Right, and we got 4 points. And these are 4 points of the quad that we can put into the immediate quad. Right, so let me find the simp. So where are the quads? Immediate, eminent quad. I cannot stop thinking about it. It's eminent quad. God damn it. Immediate quad. Interestingly, wait. So we can actually use this function, and that simplifies everything, in my opinion, because we only need 2 points in here. Right, because that's the... Yeah, that's essentially the first point. But I kinda... Nah, it's not convenient. I need to find the one that literally accepts 4 points in here. I like this one better. Because I already have 4 points. Right, I don't have to think about it too much. I already have 4 points. And by the way, I just realized that I don't really know what you can or cannot see. Right, so I don't really know what you can or cannot see. There we go. So, and let's just put it in here. So, so this is gonna be the color. Right, we already have the color. We don't need UV or any other shit. Right, so we're gonna just copy paste this entire stuff. Alright, I'm gonna put this stuff in here, and there we go. I think we did it, chat. We did it. We created immediate thick line. Okay, and it even compiles. It even compiles. So let's take a look at what we have. Right, so we know how to draw the triangle, the circles and stuff like that. So let's do immediate thick line. Right, so let's start with that. So this is a make vector 2, and let's again define some sort of a padding. So this is going to be 100. So pad. As far as I know, you can actually create a vector 2 like this. Alright, so if I take a look at the math, make vector 2. Oh yeah, so basically you can just create it with a single value, and the single value is propagated through all of the coordinates of the vector, which is rather convenient, right? So that's precisely what I want. So in here, make vector 2 is window width, window height. Alright, and for all of these things I want to subtract pad, and there we go. So, and then we can define the red color. Right, so it's something like color red. And that should create a thick line. So let's take a look. Immediate thick line, not enough. So what else does it accept? It also accepts the thickness. I forgot about the thickness. Alright, so how thick is it going to be? That's a good question. Is it going to be 20 pixels thick? Yeah, that's a good thick line. Look at that. Okay, so, and let's just go ahead and run the application. Look at that thick line. It's fucked up. So there's something. It's kind of like, yeah, it's not... We did a fucky wacky and possibly an oopsie doopsie. The fuck is this shit? I kind of understand what is going on in here, right? So do you guys see what's going on? Yeah, double baseball bat, yeah. It's twisted. Yeah, we just twisted thick line a little bit, so that happens. We did a fucky wacky, oopsie doopsie. Okay. So what do we have? How can we... Is that because I have to do some yeah, I think I have to do stupid shit like this. Stupid fucking mistakes, man. There we go. I untwisted that, motherfucker. I untwisted that. So we can actually go a little bit further. We can actually draw 2 of them just to see how they work against each other, right? So let's see how they work. The other one is going to be, let's say, green, right? So, and that one, in terms of width, is going to be window width minus pad. In terms of height, is going to be just pad. In terms of, so this is the first point, and then the second point that goes to here. In terms of width, is going to be pad. In terms of height, is going to be that. Okay, so let's take a look at that shit. Look at that. So 2 thick lines is enough. I think that's pretty poop. Interestingly, right, we can actually save those things to to variables, p0, right, so this is p0, and then this one is going to be p1, okay. So, cool. This one is going to be p2, and this third one is going to be p3. Cool. And then we can do immediate circle, right, immediate circle, p0, and let's say that the radius is going to be 30, and the color is going to be red for this one. So this is p0, and this is p1. For that one, this is going to be 2p3, and this one is going to be green. Cool. So yeah, so we have this framework that allows us to do these kind of things, right? So, and essentially, yeah, now we can draw the ropes and see how they interact with each other and whatnot. Right, which is pretty freaking cool. So, and I also refreshed my my knowledge of the of the simp, right, and the how do you do graphics with Chai. So I think I want to make a small break and make a cup of tea, right, and then after a small break we're gonna actually start coding the physics simulation, right. So we're gonna start with a single segment, right, and then we're gonna just try to chain the segments and actually simulate the rope, right. Think C-style management, but you can choose your allocator. Oh, you guys talking about the memory management in Java? Yeah. Anyway, so let's make a small break. All right. So one of the things I want to be able to do with this project is also interact with it, because I want to be able to take the nodes and just like literally move them around. So because of that, we need to figure out how to accept user input. Right. So let me take a look. The input module, I believe it should have something to work with mice. Right, so do we have mouse? So there's a mouse wheel. Input, oh, there's mouse delta X and some other shit. That's very interesting. So let me see. So maybe it's in the module, mouse. So the mouse button left, mouse delta, per frame mouse deltas. But can I actually know the absolute position, or do I only know the deltas, which is kind of weird. But sure. Okay, so in terms of like Linux, X11, mouse, button, key code, so there's only buttons in here, button release and some other shit. Okay, so how do you compute mouse delta Z as well? That's very interesting. Okay, let's find out. Grep and just mouse delta. Last mouse event minus X. Mouse delta Z, input per frame event flag update, input test. I'm not particularly sure, so I think I'm gonna go to the examples and grab the examples and see if they do anything interesting with mouse. Mouse get, okay, so some of these things call to a function called get mouse pointer position. And maybe that's what we actually need. So let me go into the module, grab rn, get mouse pointer position. So it is a thing, it's a part of the get rect, okay. It's also, okay, it exists somewhere in here, but all of that is sort of like hidden, if you know what I mean. Get mouse, right-handed, false. Aha, I see. So there's this function which might give us the pointer, mouse pointer position, the current mouse pointer position. And it can fail, by the way. Look at that. It can fail, which is rather interesting. So I don't know what to make up of that, but sure. I'm gonna just try to see if I can call to this function, right? So it's not part of the scope file, right? So scope file, so that means it is public. So I should be able to access this entire thing, which is nice, right? Okay, go. So on each frame, I'm gonna just call this function and see what's gonna happen. So we have x, y, success. I'm probably gonna ignore success. I'm gonna avoid success at all cost, exactly how the Haskell developers like to do that. And I'm gonna just like print the position and see if we get any interesting data out of that. Okay, go. Well, okay, that's pretty cool. So, and we literally get the current position. And we actually get the position outside of the screen as well, which is kind of cool. All right, I'm really happy with all of that. So that means we can use that. That means we already can use that. So, but what's interesting is that in SIMP, the left, the 0, 0 is located at left bottom, but here we have 0 located at left up. So because of that, we can't directly use these coordinates, but we can try. Right, for instance, let me actually comment out these things. So let me put it like that. Right. And then what I'm gonna do, immediate circle, make vector to x, y, and we're gonna put 30 in here, and the color is going to be red. Right, the color is gonna be red. So let's take a look at what's gonna happen if we try to do something like that. So make vector 2, and this is because x's are integers, so what it wants, I suppose, we want to cast that. Well, I mean, we can always just do something like this. Right, so this is an epic feature of, yeah, there we go, as you can see. So that's precisely the discrepancy between the coordinate systems, right? In terms of x, they spot on, right? So in terms of x, it's spot on, but in terms of y, they are inverted, right? So what you want to do in here, in fact, is probably like window height minus that shit, right? So and that will probably help you. Make vector something, but maybe here we're gonna do something like this, right? And yeah, there we go. Look at that. Look at that. So we actually have this thing that is following this stuff, right? It's pretty cool. But we want to be able to actually grab the certain nodes, right? Grab the certain nodes and drag them around. Which means we also need the state of the mouse buttons, right? So, and there's probably several ways to do that, right? So I hope there's a way to get the current state of the buttons, just like the current pointer position. That would be kind of cool, but maybe not. So the other way in computer systems is usually we do that through the events, right? When you press a button, some sort of event comes in, like button down and button up. We can use that to check for these kind of things. And I think events is the preferable way because it indicates the start of the dragging and the stop of the dragging, right? Because we're going to be dragging this stuff around. So I think that's what we're going to do. All right. So let's take a look at if we can actually detect the events, the mouse button events. So here we have events this frame, right? And let's take a look at those events. OPT, J, module, and I suppose maybe, I don't remember where they're located, but I'm gonna just grab this entire thing. Right, so let's see, where is it located? So it's commented out though, that's really weird. Maybe because I have to do something like this. Input events, is it because it doesn't have a space? Why can't I find events this frame? Huh. Alright, so what if I try to do that? Okay, oh, because it has... Thank you so much. That's exactly why I couldn't find this entire thing. So, all right, so this is a bunch of events. An event is a structure, right? Is a structure. And the structure has a type, and what kind of events type can we have? We can have, so we have a keyboard. Drag and drop files, but I'm not sure if I care about that. So there's a keyboard. I remember that there was like a mouse button. Oh, it's a I keep forgetting that. That's a kind of interesting thing, right? So the mouse button is a key event in simp, right? So you have like a F1, F2, and you have mouse button left and mouse button, which I mean, I guess. But the language is unfinished, right? So we can't criticize unfinished language, so. Alright. So let's just go ahead and do that. So if the type is quit, we just do quit. And okay, so this is my favorite part of Jai, of the syntax of Jai. I need to basically transform this if condition into switch case. How do you do that? Well, essentially you take this part, you actually take this case, right, and do case quit, and there you go, you just converted this if into the switch case condition. You can add more cases in here, for instance, right, so we have quit, and you can now have keyboard. As simple as that. You want to convert it back to if, you just do it like that. You just put this in here, and there you go, this is if. So this is how you convert like if into switch case condition, right? There is no difference between like if and switch. I really like that. It looks crazy. This entire shit looks crazy until you realize why it is done like that. People, when people see these switch cases for the first time, they get all disgusted, like, what the fuck is this shit? How dare you do it like that? But when you show them that you can easily convert if into switch case by just doing that, they all like, holy fuck, this is genius. Right? Because again, this is actually a very common thing that people do in imperative languages. You have some sort of if, and then you realize you actually want to compare the variable to several cases. And now you have to rewrite your entire if and change the keyword, change the structure, and it's just so freaking annoying. Here you just move it out, and there you go, you have a switch case. Right, so anyway. So if it's a keyboard, within the event, we can have a key, if I'm not mistaken, right? So it's a key code. Let's actually see what we can have, right? So it's a key code, and again, I can just use switch case in here as well, like so. I can even just do it like that. Boom. And the case here is basically mouse button left, right? So this is a mouse button left, and if mouse button left, we want to print something, right? We want to print click or something like this. Right, we want to print with the click. So let's try to run this program, or at least see where it fails. Okay. Okay. So I suppose there's no difference between up and down. Yeah. So you also have to check that it's pressed. Right, if it key pressed, right, and let's try to do that. Yeah, there we go. So now we only, check only for the first one. I also like how syntactically if conditions just stack together like that. So yeah, and AND operator, but how? You can't just use an AND operator in here because this is a completely different construction. This is a switch case and this is if. It's a switch case that uses if as a keyword, but it's a completely different construction. So we can try to do something like this, but I kind of doubt that it's gonna work. If it works, it's kind of actually cool. No, it doesn't work. It's a completely different construction, but at the same time, you still can stack together ifs. It's really interesting how if condition 1, if condition to if condition 3, then do something is literally the same as this. There's no, like, from the point of view of the behavior, there's no difference between that. It's just like 3 nested ifs, but also you can think of them like that. It's just like, yeah, it's just, it's kind of cool. It's really interesting if you think about it. So the syntax at first feels a bit wacky, but when you try to understand why it is like that, it kind of makes sense. And furthermore, the syntax is yet again not fully finished. Right. So some of these things may change, but whatever we have already is kind of interesting by itself. Right, it's already kind of interesting, but anyway. So, yeah, we can actually check this kind of stuff, and now we can detect when we pressing something or maybe when we unpressing something. Right. Maybe we can actually invert this entire thing, so I can take this if condition, actually put it in here, and then put else in here, and then say unclick, right? And then put then in here, right? So, okay, so it didn't fully work. I wonder why, because I forgot a semicolon in here. All right, and now we should be able to click and click, click and click. All right. Okay, so that's actually better, right? Because that's precisely what we will need when we move on with this code. Right. There we go. Cool. So let's implement the dragging, right? So we're going to have some sort of a like a head, right? So this is going to be head, and this is basically a vector. Vector at the center of the screen, so it's going to be window width divided by 2, window height divided by 2, so it is at the center of the screen. So the way we're going to render this entire thing, we're just going to render this entire thing. Head, and let's call it not radius, right? So this is going to be not radius and not color, right? Not radius. Is going to be 30, not color is going to be color red. There we go. Okay, so now we have that. So we need to introduce a state that tells us whether we're dragging the node or not. So drag initially is false, right? The drag initially is false. Now, if we're currently dragging, right? If we're currently in a dragging mode, what we're doing, we're constantly setting the position of the head to the position of the mouse, right? So this is going to be something like this: make vector 2. Like so, right? We're currently dragging this thing, and we're also currently drawing it. Okay, so if we press something, right? If we press something and we're close enough to the, if we're close enough to the head, we should initiate the dragging. But the question is, do we have the position of the mouse within the event? No, we don't, so we have to also take it from here. Right, we also have to take it from here. What's interesting is that I'm not checking the success. I'm not sure if I should care about it. Maybe I can do something like assert success. It's actually really funny. Assert success. Right, so I'm gonna just like assert. I'm gonna always assume that it's, you know, success. Do we have a distance between those things? Because maybe we can do something like make vector 2 minus the head, and then we can take the length of this entire thing, and if the distance between these things is less than the not radius, we are initiating the dragon, right? We're initiating the dragon. Maybe it would make sense to actually set drag to this, but I don't want to be a smart ass, right? So we're gonna just put it like this. And when we unpress, we always set the drag to false, right? Okay, so, and that should be it effectively, right? So let me see, right? Okay, so that kind of works, but we have this classic situation that yeah, we have to do something like window height minus, and we have to fix it everywhere, get mouse pointer position. And I'm thinking maybe I have to abstract it away somehow, right? Because that's what I do anyway all the time. Right. So let me actually confirm that it works and stuff. Right, there we go. Yeah, look at that. Look at that. That's cool. I can just move it around. I can put it somewhere here. I can put it somewhere here, and I actually lost it. And yeah, so super easy to lose it apparently. But yeah, that's pretty cool. So I want to have something that gets the mouse position. But it actually returns you just a vector 2 within the simp coordinates and stuff like that, without any of this bullshit and stuff like that. Right, so let me just grab that and put it in here. So, and then we're going to return this thing. So, and when we're dragging, then head equal mouse position. Mouse position, thank you very much, there we go. If we are dragging, this is the mouse position, and we're constantly drawing the head. And in here, we don't have to do that anymore, and we can just do mouse position. There we go. So mouse position head. If it's less, maybe we can also say equal to not radius. We're gonna set this thing to true. And again, maybe we really wanna be a little bit fancy in here. Look at that. So we're dragging when we're close enough to this thing, and when we unpress, we always set dragging to false. All right. So let me see. And okay, that seems to be working. That seems to be working. So we can move this thing around. Cool. So we probably actually want to have several nodes, if you know what I mean. So let's introduce something like tail, right? And a tail, I'm not really sure where we want to put the tail, but let's put it somewhere in the left, maybe left bottom corner, right? So something like this. So this is going to be like a third of this entire stuff. And for the tail, we're going to use a different color so we can see what we can or cannot grab, right? So for now we're gonna say that we cannot grab the tail, right? So you can only move around the head. So not color, I'm not sure not color is a particularly useful thing. So there we go. So the red, it's actually color red, and then color green. There we go. Okay, so I cannot grab these things, but I can grab this thing. Okay, so we have these two things. On top of that, we probably want to connect them together, right? So let's do something like immediate thick line, right? So immediate thick line from head to tail. And what kind of thickness are we going to have? So let's go for 30. And the color we're going to use, I want to probably use something grayish. Right, so something like 20, maybe 50. Let's actually put half of those things like so, and let me see what we have. Right, and that's basically what we have, right? So we have this sort of junction that we can move around. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. That is very freaking cool. Okay, so we can now introduce a velocity of the tail, right? We can introduce some sort of a velocity of the tail, which will update depending on the relative position between the head and the tail. Okay, so so here we have a tail position, and then we're gonna have a tail velocity. So initially, the tail velocity is probably gonna be 0, 0. I don't have to provide the second 0. I can just put this thing in here. But one of the things we need in here, right? We will need the delta time. And the question is, how can we compute the delta time? I don't really remember. So, but maybe there's something in examples. J modules simp. Let's take a look at the examples. And when we organize the event loop, right? When we organize the event loop, we sleep, which is actually a good idea. Sleep milliseconds. I think we also should sleep. Thank you so much, John. Very cool. We're also gonna sleep a little bit to sort of reduce the busy looping and shit. And in here, so there should be a way to get the delta time. Okay, so here we get the time, right? So we get this certain time. And where do we use this time? Where do we use this time? We do theta time. Okay, so we don't have delta time. Right, so we just use the current time as the parameter. Microbic Music, thank you so much for 8 months of Tier 1 subscription. Oh shit, I finally got the mustache after 4 years. Oh, you're referring to the thing in the, like, in front of your nickname here. So this one. Congratulations on your mustache. Thank you so much for the subscription. Alright, so it's just like this Twitch thingy majingy. So I remember that in Jailbreak, the game that I made long time ago, so if you never played it, I really recommend to check it out, Jailbreak. Right, it's written in Jai, right, but it's compiled to WASM. It was also a pretty interesting project to explore how to compile Jai to WebAssembly. So we got a lot of interesting results out of that, that's for sure. So I remember that in here I computed the delta time somehow, so maybe I can steal the way I compute delta time from there. Jailbreak, let me see. So this is a game, delta time, so render score, There was update. Okay, so here's update, and we accept delta time as part of the update. I also remember that we have something outside, something that calls update all the time. Right. Oh, we literally used get time, right? So this is the last time, then now, then we compute delta time. Yeah. Okay. It's a really interesting way to do that. I guess that's literally how we do that. Sure, we can work with that. So we're gonna have a last time. Sure, this is the last time. So then we get now, like so, and we compute delta time. Delta time. In 64, and then we cast that entire stuff to float. I mean, why not? Sure, it's kind of weird, but it's fine. And then we just compute the last time. So at the end of the frame, we just swap the buffers. Nothing particularly special. So I guess we can work with that. So here's the current delta time, and we also need to include the time, but maybe it's already included by the basics, so we don't really have to think about it too much. Okay, so now, cool. So everything seems to be compiling at least, right? Everything seems to be compiling. And now here, when we're dragging, we're doing that, then we're rendering this entire thing. So the other thing I wanted to do is just to do tail plus tail velocity, but multiplied by the current delta time. But since the tail velocity right now is 0, it should not update it. So everything should stay as it is, right? Everything should stay as it is. And one of the things now we can do, right? We can update delta velocity, tail velocity, depending on the distance between the head and the tail, right? What was the reason for the slip again? To reduce busy looping. All right. Now, so the distance head minus tail, and we take the length, right? So what's the best way to do that? All right. If it's too big, right, we also need to define what's the optimal distance between them, like what's the distance that we're looking for. Right, so distance, maybe let's call it target distance. And let's say that the target distance is going to be something like 100 pixels, right? So this is going to be the target thing. If the length is bigger than the target distance, that means, right, that means that the tail velocity has to be, heading towards the head, right? So that means we need to take the head minus tail, and we can just set that that's actually very interesting. What if we just always just set this thing? But I mean, nah, yeah. That's very interesting. So we can essentially I'm just like having random thoughts right now. So we can essentially do the following thing. So you have a head and the tail, right? And you have sort of like the target distance. Knowing these vectors, you can compute where the target position, and just always set the velocity to point at here. Just like always set it to point at here. Right. And the farther away from here you're gonna be, the longer this vector is gonna become, the closer it is, the shorter it's gonna become. And if this particular tail is gonna be here, it's gonna be pointing back to this position. This is a really funny way to do that. Right, and it's actually relatively simple. But my brain is actually slowing down, so I think I'm gonna just look at the chat and see what people are saying there. Hello there, hello, how are you guys doing? Is the code using bindings to Olive C? Why? The point of Olive C is not to use it everywhere. That's not the point of Olive C. Why people ask it? Like, it's kind of weird. Like, I explained the point of this entire library at the first stream of Olive C, and the point is far away from using this library everywhere and replace everything. It's just like, it feels like people really assume that I'm trying to make the ultimate library that will replace them all. It's like, no. No, it's actually very much opposite. Olive C has a very narrow, very specific use case. It's just like, it's very, very narrow. And you definitely don't want to use it everywhere, but it's just, I don't know. I don't understand these people. Overhype syndrome. Yeah, I guess it is. It's like people like to be part of the team, and if you're not using the thing that identifies the team, you're not part of the team, you're a traitor or something like that. It's just, like, people use languages and libraries as these tokens of being part of this tribe or something. It's so weird to me. I just like don't understand. Like, software development culture was nothing like that 10 years ago, right? It's just so weird to me. Okay, so let's just try to do that. So here's the length, right? So here's the length, and I probably want to actually keep this length between head and tail somewhere here, right? So this is that. So this is the target distance, this is the length. And now I probably want to do the opposite thing. I want to take the vector right? That is pointing towards the tail. So I want to do tail minus head, right? And I want to divide it by length to get this thing sort of vectorized. But again, we have an interesting situation when, what if the length between them is 0, right? What if the length between them is 0? What do we do in that specific case? Well, I guess we do nothing, right? So maybe we can just check for that. If it's less, if it's greater than epsilon, and where is that epsilon, by the way? We already used that epsilon somewhere. I'm thinking I'm gonna actually promote it to a constant. Right, so it is promoted to a constant now. There we go. Cool. So okay, so epsilon, and here, if it is greater than epsilon, we're gonna do this entire thing. Cool. So this is opposite direction, which we want to multiply by the target distance now, and we got the target point. We can even call it just target, right? So this is target. So, and what we're gonna do, we're gonna set the velocity target minus tail. All right. So, and it's sort of like constantly moving towards that specific place to close the gap between the distances and whatnot. All right. So, yeah. And then we update this velocity. All right. So this is rather interesting because what does it imply? What does it imply? It implies that the distance between head and tail is so small that we don't know in which direction we want to move them apart. So that's what it means. We don't know in which direction we want to move it apart, which means that we can just pick a random direction in that specific case. You know what I mean? So this is actually kind of cool. Yeah. This normalize function made me realize that I never care about the case when the length of the vector is 0. I never actually cared about this case, but this case is important. Especially it's important to think what it implies for a vector to be 0 when you normalize in the vector. So in that case, that means we don't know in which direction we want to move them apart. So can we handle that? We kind of can handle that. We can pick a random direction, or maybe we can use the fixed direction. It's not a bad idea. So actually looking through the John's code, I learned something. I learned that I never cared about a very important thing. Yo, that's so cool. Holy shit. It definitely was like that 10 years ago, but those people were isolated in their own mailing lists. Oh, okay, so that explains it. It's just like my entire sort of 10 years ago, I was hanging out in XMPP service, in a Russian-speaking XMPP service when I was learning programming among other people who was doing programming. And it was actually anti that completely. And we used to like create the conferences that were about all of the languages at once, right? So, and we pretty much hated this idea of being the X programmer, meaning that the Java programmer or C++ programmer or something like that. I just sort of, as a programmer, I grew in an environment where we treated programming as its own thing, and the languages are just the tools that you use, and they're less important than what you do with those languages. And it was like very important for us. Like I grew as a programmer in that specific culture, and I don't understand when people put tools at first. It looks so weird to me. It's prevalent more in the Western internet. Okay, it's just really weird. Because at the end of the day, it's what you made with those languages, not the languages themselves. Right, that's what's important. And it gets more absurd and absurd. So at these days we put text editor at first, then language the second place, and only then what we do. You know what I mean? Like first, like you have to really like rise your text editor. Then you need to pick the new trendy shiny fucking language, and only then maybe if you have time you can decide what kind of project. You can write hello world in it, like who fucking cares, right? So it's just like this is what I don't understand, and I'm not sure if I like it. It's just like there's no place for me in this culture. It's just like no. Anyway, so whatever. I mean, I agree that some languages, they have cool features and they solve some problems, but for me, language was always like the second place. It's just like whatever. So the first place is what I do, the project, right? The project that I make with this language. Okay. So we already, yeah. So what I was talking about is, I can pick any direction. The direction is actually determined by this thing, right? So I can say that this is the direction, and I can just like multiply this thing. And since the direction can be still defined even when length is epsilon, I can actually move that away. In fact, I can use something like if x. If x is basically ternary operator, right? So right, it's a sort of if as an expression, right? It's if as an expression. If that, then that. Otherwise, I can pick a random direction. I can just like do something like 1, 0, right? It's also a unit vector with length 1. I think that's what it's called, unit vector. All right, and it's just like we'll move to whatever, right? So it's just like move it away, and that way, yeah, should work. Probably. Okay, let's give it a try. And it actually... Ooh! I like that. The distance is too big, because it's 100. What about 20? Snake. Maybe it is snake. It's moving towards 0. That's weird. Okay. All right, so let me think what's going on here. Let me think what's going on here. So head and tail. So this is the length. And then maybe I specifically have to do, well, I mean, it shouldn't matter, right? So it just doesn't matter. Then the target, oh well, okay, so it has to be head plus certain direction, multiply. Okay, so that explains it. That freaking explains it. Okay, so, that's cool. We can put even 100 in here. Alrighty, boom, boom, boom. Yo, that's so cool. Holy shit. Okay. I love that. So we can actually make it a little bit faster. We can always like multiply that by something like I want to make it twice as fast, right? Let's actually make it twice as fast. Yeah. So it should be a little bit snappier. What about 10? Right, it should be like very snappy. Yo. Oh, that's so satisfying. Holy shit. Oh my god. That is so cool. I do not regret starting this project. It was so worth it. My god. Window factor. window factor, creation factor. So let's say it's gonna be 75 or something. Okay, maybe even 100. Okay. So yeah, that's cool. Yeah, people were asking that in the chat. I did, in fact, I was in fact inspired by Advent of Code, by today's, day of Advent of Code. So yeah, I already solved it. So, but the day 9 actually discrete, and I wanted to do something like in continuous space, right? So, and I think this is how it would roughly look like in continuous space. So yeah, that's pretty cool. Okay, so the question is, how can we now chain this entire process together? Right, so that's the most interesting part. How do we chain this stuff together? To chain this stuff together, we need to sort of like have some sort of a function. I just joined. Is there a reason you're using Jai that suits this problem? Yes, there is a very specific reason to make all of you who don't have an access to Jai freaking jealous. Got him! I'm sorry. So there's actually no reason, no particular reason. It's just like I'm developing, I'm doing all of the Advent of Code's code days in Jai. And I kind of felt like to do this thing in Jai as well, since it was inspired by Advent of Code anyway. Jails, yes. Alright, so... okay, so we need to have some sort of a function that accepts head, tail, and tail velocity. And we should be able to update the tail velocity. In fact, essentially tail vector, tail, not vector, tail velocity, is a function of head, vector 2, and tail. So the tail velocity doesn't depend on current tail velocity, which kind of makes it super easy to chain them together with this simple function. Right, so that's pretty cool. So how should I call it? Compute tail velocity. So let's just call it compute tail velocity. And so here we have target distance, and we also have this parameter, which makes it a little bit snappier, right? How would you call this parameter? So the bigger this parameter is, the faster the thing moves towards the target distance, right? So for instance, if I put 5 in here, well, I haven't factored out properly yet. Okay, so I just have to return this thing. Elasticity. We can call it elasticity, sure. Elasticity. Right, so it's gonna be 5. And sure. And here we're gonna just do head and tail. There we go, and we can get rid of this entire stuff. Alright, and then we update the tail and so on and so forth. Cool. So now it's 5. I set elasticity to 5. But now, if I set it to, for example, 20, it becomes a little bit more rigid. Right, so it snaps a little bit fast. Damn. That can be used in some sort of a game for sure. I really like that. That's so cool. It will be also kind of cool to be able to drag any of them, but it's kind of... we have one directional interaction between them. So it's basically the position, the velocity of this thing is based only on this thing. And if we're gonna chain them together, the velocity of previous one will depend on the next one. But if we want to be able to actually drag any of them around, we'll have to do bidirectional dependency, you know? So the velocity of the middle one should depend on the positions of both of those things. And yeah, it has to be like codependent between all of them. So we'll have to think how we can do that, if we even have time to do that, because we already streamed for more than 2 hours, so I'm not really sure if I'm gonna actually go that route, but that's already kind of cool. Anyway, so let's actually make a tail consist of several things, right? So let's say the tail is basically a vector of 10 things, right? So it's going to be vector 2. So we can have something like tail length, right? So let's say we're going to have 2 of them, right? So for now we're going to start actually pretty simple. So this is a tail length. There is a 2 of them, and a tail velocity is also going to be tail length vector 2. So the question is, how we're going to be initializing this tail, right? So how we're going to be initializing? I suppose we can just iterate the tail and just do something about it, right? So maybe we can iterate it by a pointer. So I can do it, and then I'm gonna just assign it, make vector 2, right? Make vector 2. Maybe I just have to put like a random shit in there, but the random number generators, I remember they are a little bit painful in Jai, right? So let me see how I use them in Jai break. So where is the random? Oh yeah, there's not actually, yeah, so they're not painful. You can just do random get 0 to 1, so it's actually pretty straightforward. I don't know why I decided to do a slander on Jai, because the language is unfinished anyway. So let's actually just pick a random thing between, like, within the window, right? So we can just do something like this. So this is width, this is height, and there we go. Okay, so will that work for us? Let's see. So we probably have to import random, right? So let's see if we have random. It didn't work because it's a width, and width height. What the fuck? I meant window, not width. So what else we have in here? So this is the tail. Oh my god, I'm already falling asleep. I'm doing very stupid mistakes. Stupid fucking mistakes, man. Okay, so this is gonna be 0, right? So we compute tail velocity, and the tail velocity of 0 depends on this thing. Interestingly, right, so what we have to do now is just something like this. I'm gonna be iterating from 0 to tail count, but -2 actually. Right, so we have 2 of them, so that means I'm gonna be iterating only 1. Alright, so because if I have only 2 of those things, I'm just thinking, should I have had as something pretty much separate, as a separate entity, or should I make it part of the whole tail? At least for now. So when I will be able to grab any node and move it around, it will make sense to make head part of this rope. But since we can only grab head, maybe it's more convenient to keep it as a separate entity. You know what I mean? You know what I mean? So it's just like easier to do it like that. Right, so because of that, yeah, I'm not sure. Alright, so then we're gonna be iterating from 1 to 1, right, which means that the tail velocity of it is going to be compute tail velocity. So head is tail it -1, but the tail is the tail it. Yeah, cool. So after that, I'm iterating the entire tail, right? But maybe I'm gonna do that from here. Right. And the tail it velocity. So after that, I'm gonna be iterating for 0 tail count -1. Count -1. Tail it. Alright. So we also need to draw the lines, the thick lines between those things, right? So we drew the head, and then the thick line between those. So that means we kind of want to do a similar thing. Kind of. Kind of want to do a similar thing. But we need to actually draw the thick lines first. We need to draw the thick line first, and only then draw the knots on top of them. Yes. So that makes sense. Okay. So let's actually start it like that. So we're only drawing the thick lines. Okay, so the thick line from head to tail 0 specifically, like this. Then we go from 1, but here we're drawing tail it -1, tail it, right? And then we're iterating one more time. Tail count, I said. Emacs, don't be stupid, Emacs, please, I beg you. Tail it, and this is green, color green. Okay, I'm gonna just try to compile that to see if it makes sense to the compiler. Okay, and then I'm gonna read it to make sure that it makes sense to me. Alright, so compute tail velocity. So the tail velocity is the head, that, then I iterate through that. So for the current tail, the previous section is the head, so that makes sense. Then here we update all of them. Then we draw that from that. Okay, so it kind of makes sense. Let's go ahead and just run this entire thing and see if it's working. It is in fact working. Look at that beauty. Holy shit. Yes. That's so cool. Yo, that's so fucking cool. I like that. That's so fun. And it's such a simple math, actually. It is so simple. Holy fuck. Okay, so what that means is that we can add more things in here. Okay, let's add another one. So, yep. So fucking cool. So what we're doing is that we're just making sure that they stay at the required distance, right? You can make a game out of that, right? You can use it in a game engine and shit, and it's just like, holy fuck. Okay, so what about 10? What the fuck was that? I mean, I kind of understand. So since we generated like a random, it just went crazy. Oh my god, that's so cool. Oh my god, holy shit. Okay, so what if we actually make it less elastic? So since it's bigger, I think the elasticity could be a little bit more snappier, in my opinion. Right, so yeah, that's so bold. If we make the elasticity like very much elastic, I don't know what that's supposed to mean. It's gonna be, yeah, that's basically what's going on here. Yeah. And what's interesting is that now we can parameterize that, right? So who said that we have to use the same distance and elasticity for each of them, right? We can actually use different distances, right? So as you can see, these two things are hard-coded. Who said we can't put them as a parameters as well? So, and maybe make some sort of editor that allows you to control those things and stuff like that. So we can also do that, but yeah, I'm not sure if we already have time for that. So, and another interesting step would be to, again, make the interaction bidirectional, right? So essentially, we only go in one direction, right? So we have a head, and the head affects the tail, that tail affects another tail, and so on and so on and so forth. So it's just chain goes back into the tail. But if we want to be able to grab any node, right? If we want to be able to grab any node, that means we have to propagate that information in both of the directions, right? So which raises an information, a question, like how do we do that, right? So, all right. So essentially we have this sort of situation. We have three nodes, right? Three nodes. And let's say that we are kind of computing the velocity only for this one. We don't really care about these ones, right? We don't care. We only care about this one. So what we can do in here, we can essentially find out what has to be the distance. What has to be the distance, like what's the target distance? Let's say the target distance in here is going to be this. And the target distance in here is going to be this, right? So that means this particular node wants to go here, but because of this thing, it also wants to go here. Where should it go? We can basically take this as two force vectors and we can sum them up, right? So that's one of the things we can do. We can just sum up these force vectors, and since we're computing that for each individual node, this node will also affect this one, making this thing also move in that direction. So they sort of basically on each frame they will get closer to the right thing. So they will try to sort of resolve the entire system, but I don't know. So this is how I see that, but I'm not sure if we have time for that because we're already streaming for 2 hours. But overall, I think this is how I would approach that. Yeah. Oh my god, this is so cool. My god. Will it converge? Probably. I mean, why shouldn't it? Okay, so let me make the elasticity something like 20. So it's really funny. Okay. That gives me so many interesting ideas for instance, for a game. Yeah. So that's so cool. And that's probably why it makes sense to solve Advent of Code, because it gives you so interesting ideas, like an inspirations for some stuff. So yeah, let me maybe put a license in here, right, and just upload it to GitHub for anyone who's interested. Okay, so let me run this entire thing. Yep. What about making 100 of them? So we have, okay, so maybe 100 is too much. What about 20? All right, so let's just untangle them. Right, so essentially what I want to do, I want to actually find a good thumbnail. Maybe that's a relatively good thumbnail, so let me do a screenshot. Readme rope simulation. All right. Quick start. Jai Linux version. What's the version? Okay, so this is the version that we have. So since Jai is constantly changing, right? I always include the version with which it works. Right, and then we just do Jai main.jai and just run this entire stuff. So then we're gonna include the thumbnail, thumbnail PNG. Okay. Go. And also we probably want to git ignore the binary. Let's do git init. Okay, so I didn't really want to do that. So let me unstage this thing and let me git ignore build. There we go. Ready, set, go. There we go. And let's create a repo. So this is going to be public rope j rope simulation in j. Okay. And I'm going to copy paste this thing in here and add the remote and push that right into the repo. Look at that. Look at that. So yeah, if you have a J compiler, you can try to compile it on your machine and see how it works. So yeah, that's basically it. It was actually so cool. Yeah. I'll see if I'll make another stream, continuation of the stream that just basically, you know, allows you to grab any of this node. Yeah. You could probably make a snake game out of that. So yeah. That's so cool. Does anyone have any questions maybe, or before I go? That could be probably better thumbnail, so I should probably update this thumbnail. Shouldn't be easy. How do you measure the easiness or like difficulty? Like by what criteria it's easy or difficult? So okay, I'm gonna put this stuff in here. Nail. A better thumbnail. I'm gonna push that right into the repo. Do you think using J for this helps you compared to if you do this in C++? I don't care. As already said multiple times on today's stream, language for me is a second thing. I care about it less than about the project. The project is more important. Like my answer, I don't care. It's just like I couldn't care less about it. Especially I couldn't care about comparing how difficult or easy it is between the languages. It's just like an ultimate waste of time. All right. Okay, that's it for today, I suppose. Thanks everyone who's watching right now. I appreciate it. Have a good one, and I see you on the next streams, I suppose. I didn't update the thumbnail, even though... Did I push the latest thumbnail? Yeah, I did push it. It's just like the browser didn't update it. Okay, so maybe we should raid somebody. Do you guys have any suggestions on who should we raid? Is anyone doing any epic Jai development today? So we have to wait for Twitch, of course. Of course. Okay, Jessica Mac. We could raid her probably, but I don't know. Let's raid Jessica Mac. I think, well, she's doing also like graphic stuff, so it makes sense to raid her right now. I wish I could just like mute myself super quick. Okay. Fuck. Twitch is so slow. Oh my god. It's unbearable. Raid. I'm just like, I just give up. Jessica Mac. It's terrible, terrible. Oh, it shows me different pop-ups. I don't care. Oh my god. This is painful. Like, who developed this shit? So bad. Okay, so, alright. Thanks everyone who's watching right now. We appreciate that, and I see you next time. Love you.